Hello, my name is Robert Wen from Salesforce. Thank you for attending today's presentation. In this presentation, I'll be sharing with you our team's use cases for developing pipelines as code. Let's get started. In this presentation for pipeline as code, I'll be using quite a few sample modules and sample source code to illustrate our use cases and how we develop shareable modules for pipelines. First, a little bit about myself. I'm part of the Einstein production engineering team. We are responsible for this. We are responsible for CI/CD pipelines, DevOps, and developer productivity. Here's a little bit background about this presentation. Early in the year, we adopted Spinnaker as a deployment orchestration tool. There are quite a few key considerations for how to implement and maintain pipelines, including multiple environments from development staging to production. We have pipeline stages for environment, which generally speaking are quite similar across applications and services. We need to be able to use pipeline modules for reusability purpose. As a result, we can develop new modules or new pipelines for applications more efficiently. Another key point to address is we must enable pipeline change control. This point mainly is about to restrict who can submit source code change, who can review pull requests, who can apply source code change onto pipelines. Given all these considerations, we enabled Armory's pipeline as code feature. This feature helps us meet these requirements. Here is a high-level description of pipelines as code as a service. So the background service is called Dinghy, is operating as one of the microservices operating within the Spinnaker installation. It is listening to code change in GitHub. Once it detects new change and it does source code change checking. Once checking is done, you apply the change onto pipelines. To prepare for the pipelines code, there are a few phases involved: setup, preparation, construction, and expansion. Setup mainly involves just enable the feature itself, the pipeline as code feature in Spinnaker, and restrict access to a designated repo for managing the pipeline code in GitHub. During preparation phase, we select pilot applications for pipeline code implementation. We define pipelines using the Spinnaker UI. Then we move on to construction. During this phase, we develop pipeline code based on the pilot applications. This involves quite a few steps. I will go into a little bit detail and using examples in the following slides. And after construction, we're ready for expansion. What that means is we are ready to onboard all services and applications based on the outcome from the pilot applications pipeline code and the shareable modules from this experience. The setting up pipelines code feature including the Dinghy service. This service keeps pipelines and GitHub repo in sync, and it fetch changes in modules. It apply change to pipelines. Another key feature to enable is OFC, the role-based access control. This is a very critical capability we need to enable because we need to restrict access to applications, pipelines, and accounts. We need to be able to custom permissions for automatic and manual pipeline triggers. And of course, we need to prepare the GitHub repo. This in our use cases, this is a mono repo. We store the pipeline configurations. We enable the pull request review and restrict who can apply the code change. During the preparation phase, we select the pilot applications. Basically, what I mean is that application is ready to onboard onto Spinnaker. There are few conditions must be met. First, the Helm charts are available. The override values for each application is available. We are able to deploy using this Helm chart and override values using Helm client. Once those preconditions are available, we can coordinate with the dev teams for the pilot applications. And so we define the pipeline implementation schedule, trigger types, and pipeline dependencies. For example, the production deployment version must match what's being deployed in staging. The next step in preparations will define the pipelines using Spinnaker UI. Using the UI, we can define the most common stages between applications and environments. For example, the big query namespace, the menu judgment, deploy manifest, and run script stages. We're also using the UI to define the common triggers, for example, Docker registry or pipeline triggers. After the first two steps, we can go ahead to create pipelines for a pilot application. This is a sample application, a sample pipeline for a sample application. In this case, it's a LDAP pipeline. So we have a configuration, baking, namespace, and the application deployment. After application deployment, we run integration tests and notify Datadog. And as you can see from this slide here, from the application pilot actions button, we can retrieve the pipeline code in JSON. Well, based on the pipeline code in JSON, we can extract the modules from the pipeline code, including artifacts, big query namespace, deploy manifest, and run script. We'll identify global variables, parameterized modules, and organized modules in GitHub. This is a sample output of a example application. We have a Dinghy file at the top level. So we have one Dinghy file per app. We have the modules organized into stage modules and app-specific modules. But this is an example. We have one sample application and the sample application, and here are the stage modules, which can be shared between applications. Here's an example of a top-level Dinghy file with the application name, with the global variables, and an array of pipeline modules. So each of these pipeline modules are corresponding to a specific environment, for example, dev, staging, or production. During the construction phase, there are many steps involved. One of these is the app-specific modules. In this example, what we're seeing here is this sample app module for a dev environment. So you have bake, create namespace, deploy app, and notify Datadog. For this example, we have a Docker registry trigger. You happen to be using a regis, expression. So in this case, only Docker image with tags that match this pattern, basically 4 digits dot and 2 digits dash snapshot dash another number. So this is one of the example is when we tag the Docker image using year, month, and the build number. So only those tags will be picked up by this Docker registry trigger. In this app-specific module, among these modules, we also need to define some variables for artifacts, such as the common chart names version. So the common charts should be used by all apps, and the Docker image name and path are specific to an app. The common charts is used by many apps, but there's also examples where different apps may use different common charts. So that's why this part still a app specific. We also have override values. For example, the override values for specific environment, for example, dev, for staging and production. And we also have the path to the artifact reference. These are specific for an app, but it's an app, so they are we need to override values for these shareable modules. So this is an example for artifact reference shareable modules. There's another example for manifest stage. So the input artifacts, Helm chart, override values, namespace, override key value pairs, ref ID, requisite stage ref IDs, or the can be defined when we're calling these shareable modules. And this module, for example, can be used by multiple pipelines and applications. The next example is for namespace. And we have account, name, requisite stage reference IDs. All these must be defined when we're calling this particular shareable module in order to create a namespace for a pipeline. The next example is a default deploy manifest. For this shareable module, when calling this shareable module, we need to define the parameters for account, manifest, artifact ID. Typically, this ID is defined in the base stage. We pass the parameters for namespace, requisite stage ref IDs, and restricted execution window. So all these are optional. For the restricted execution window, for example, you can define only execute deployments every Thursday, 3 p.m., for example. The next example is the Docker registry trigger. In this module, when we're calling this shareable module, we need to pass the parameters for the registry, the organization path in this registry, Docker registry, the image path, and the surface user. The surface user must be granted permission to execute pipeline against a specific environment, for example, staging, production. Again, the tag is can by default any tags match. You can specify particular patterns using regis. So run script is nothing more than a webhook call to invoke the integration tests. In practice, this is a script making a post method call to our CI system, which happen to be TeamCity or any CI system, and this will just pass the build type ID, and subsequently this stage will just trigger another test job and check for result. But again, this is one of the share module can be used by multiple pipelines or applications. The next slide here is about the enable change control. This includes quite a few key steps. We start by enable pull request review. So only authorized personnel can review pull requests. We designate user group for merging pull requests, and we enable Dinghy file check in pull request validation. So what that means, this is basically this step will make sure the Dinghy file is a proper JSON file. After the previous phases, we are in a stage that we can onboard more applications and services. From the pilot application experience, we develop pipeline code structure, the application modules, the stage modules. Therefore, we can work with all the dev teams to schedule pipeline development for all apps and services. During this experience, we were improving the shareable modules when necessary. One reason is some service may be a little more complex than the other, and we need to figure out how to accommodate this complexity. There could be this complexity may due to dependency between different pipelines, or we need to deploy multiple jobs within the same pipeline. And during this experience, we can improve the share modules, and the result is the improved share modules help us to onboard more services and applications. So it's very important at this step we communicate with all dev teams about the positive outcome and benefits while developing the pipeline code for pilot applications. So when other teams see our positive results, they will feel more confident to onboard more services for using pipeline as code. So in conclusion, here's the what, why, how about pipelines as code. We onboard applications efficiently by using shareable modules. We organize modules into app-specific and stage modules. We enforce pull request review against pipeline code change. We automate pull request validation check and restrict users who can merge pull requests. And final point is we have been revising shareable modules when onboarding new apps. From this experience, we have modules more extensible and shareable for current and future services. From this experience, we can continue to expand the pipeline as code for new service, for new apps and services in order to meet our business growth. That concludes this presentation. Thank you for watching. Look forward to hear your questions and inputs. Enjoy the rest of Spinnaker Summit. Thank you.